Right, James, good morning. We're going to do a little lesson on corrections from the work we did last week. So we're going to do all of the questions of simultaneous equations, and then it was question 4, 5, and 6 of inequalities from the strengthened. So I'm going to use my new black pen. Hopefully it will be visible enough. If it is truly awful, please do let me know and I'll try to write a little bit bigger. Or yes, let me know. Feel free to keep your microphone on if you want to chime in, but don't just always keep shouting in. If you have something to say, please feel free to ask it though. Right. Cool. I think that looks good for now. So I'm going to close the door. And let us begin then. So the question number 1, simultaneous equations, was solve 3x plus y equals 10 when... So question 1 was asking us to solve 3x plus y equals 10. Actually, I might turn. I think that light isn't helping. Is that better or worse? Oh. No, I'll turn off. I think the glare. Yeah, okay. So 3x plus y equals 10 when y is equal to 3. So what we're going to do here is we're going to substitute in the value y equals 3 into our equation, and we'll see what we get for x. So these are simultaneous equations. We have one equation here, and we have another equation that is y equals 3. So whilst this seems like it's a relatively simple substitution of substituting 3 in for y, no, Alex, just started. So it is just a simple substitution. It is still a simultaneous equation because we have two equations that have the same values for x and y. So we'll take our 3, substitute in the equation, give me 3x plus 3 equals 10, and then we'll solve for x. Subtracting 3 from both sides gives me 3x equals 7. Dividing both sides by 3 to get the x by itself gives me x is equal to 7 over 3. I would recommend that we leave it as 7 over 3. If we convert that to a decimal, we get 2.3 recurring, and we don't like recurring decimals. So unless the question specifically says give your answer to 3 decimal places, leave it as 7/3 or 7 over 3. The next question, very similar, the same 3x plus y. We now want to find out what x is when y is equal to 2x. So y is now, shall we leave it on there? So y is now 2x, and we still have 3x plus y equals 10. So again, we substitute our value for what y is into our equation. So y is 2x. So wherever I see a y, take the y out, put the 2x in. So 3x plus 2x equals 10. Simplify by collecting our like terms. So 3x plus 2x is 5x equals 10. Then to find x by itself, divide both sides by 5. X is equal to 2. Oh, we're not. Sorry, go for it. We're not. Has it?
Yeah.
Oh. Can anyone else see me? Okay. Maybe try and leave and come back in. I'll a second. So we're not. Okay. We're not quite finished yet because to solve these equations, we need to find the value for y as well. So y is equal to 2x. So we take our value of x is equal to 2, and then we substitute that back into that. So y is equal to 2 times x, or 2 times 2. So y is equal to 4. So those are the solutions to our two equations. So y is 4 and x is 2. And then for our first one, x is 7 over 3 and y was 2. Please do mark along and correct as we go. Oh, I've missed my dirty old green t-shirt for work on the board. Might take him home and give him a wash. The next question I can't really write on the board. It's more of a sort of like more of a discussion-y question. So what we're doing is we look through that question and see where his work. Oh no, I lied. That's question 3. So question 2 we will do actually. So now we have Similar to the first question, so it leads on nicely from the first one. We now have these simultaneous equations, 4x plus y is 12, so it equals 12 rather, and y equals 2x. So I'm going to start by writing those out. 4x plus y equals 12, and y is equal to 2x. So in class before, the main method we used for solving simultaneous equations was to eliminate one of our variables. In this case, we're going to substitute because that's what we did in question 1, but I'll also show you how we could have done it with elimination if that's the method you're more comfortable with. So the easier one to substitute, quite clearly, is going to be this equation into this equation. So I'm going to call these equations 1 and 2 just for now. That's what I'm doing. So we're going to substitute 2 into 1. So when y is 2x, so y is 2x, so I'm going to substitute in our 2x for this y here. So equation 3, let's call it now, is going to be 4x plus y, which is 2x. So 4x plus 2x equals 12. Obviously, we want to collect our like terms to give me 4x plus 2x is 6x equals 12. And very similar to the first one, divide both sides by 6, x is equal to 2. So there is the solution we think it is. We can check later. We think that x is equal to 2. And if x was 2, if x were 2 rather, we can now find out what y is. I'm going to substitute x equals 2 into equation 2. So y is equal to 2x means y is equal to 2 times x, which is 2 times 2. So y is equal to 4. So our solutions are x equals 2 and y equals 4. We found our y value by substituting our x value into equation 2. So I'm now going to substitute my x and my y into equation 1 to see if it works. And if it does work, it's probably right. It is right. Probably right, actually, might be right. It's not. So I'm going to substitute x is 2 and y is 4. So 4x plus y equals 12. 4x is 4 times 4. Because x is, no, it's not, it's 2, I apologize. 4x is 4 times 2. And y is 4. So we've got 4 times 2 plus 4 equals 12. And let's check that that's true. So 4 times 2 is 8. 8 plus 4 is 12. 12 equals 12. Yeah, I'm happy then. So both equations work with these values for x and y. So I'm happy to say that these are my solutions for my simultaneous equations. Any questions? Cool. So I have a question 3 together. If you haven't got it open in front of you, please take a second to grab that open if you can. And we're going to just sort of talk through question 3. It's not worth me writing it all out on the board. It'll take forever. So question 3a says, check this solution to the pair of simultaneous equations. So he's numbered it, question 1 and 2. He's rearranged 1 to make y the subject. Yeah, looks good so far. He's taken 2x from both sides and divided both by 3. Looks fine. Substitute in. Simplified. So I'm not checking his maths at the moment. I'm just checking his method. So he's substituted that new equation 3 into 2. Now looks fine. Solve to find x. Substitute x into first equation like we did. Actually, we substituted equation 2, but similarly, and he got that. So, it looks good. So I haven't done much more than just sort of brief look, but his working does look good. So what we're going to do is actually formally check it as it asks in part 3b to see if they work. So he's got x is 2 and y equals minus 3. And we'll see if 3x plus 4y does indeed equal minus 6. If it doesn't, then his solutions don't work. So the equations, so the equation has us 3x plus 4y equals minus 6, and x is equal to 2, y is equal to minus 3. So let's see if it works. So 3x is 3 times 2 plus 4 times minus 3. So plus 4 times, I'm going to put a bracket around my minus 3 to show that minus belongs to the 3, equals minus 6. 3 times 2 is 6. 4 times minus 3, or 4 times 3 is 12. Negative 3 makes that negative 12. 6 minus 12 equals minus 6. 6 minus 12 does equal minus 6. And so we can say that we're happy that these solutions do work for that equation because our left-hand side and our right-hand side both equal the same thing. So our initial sort of guess that it looked good, we've actually made that formal check now and say that not that it looked good, it is correct. So question 4 does specifically say, it doesn't specifically say, it says in the hint, you can use the method in question 3, so rearrangement and then substitution. I did say earlier on I'd show it by elimination, and I actually forgot, so I'm going to do that now. So we'll do this equation in both the ways that it can be done. It can either be done like it was in question 3 with the rearrangement and substitution, or we can do it by elimination, which is the method I think we're generally more comfortable and more used to seeing. So we'll do both methods and we'll see which one we like best, and then whichever one work. I mean, both methods will work. In certain situations, one method will be better. Now, personally, with this method, I would use elimination rather than substitution. I think it's the better method for this equation, but they both work as long as you get them right. So we'll do it first by substitution and rearranging substitution. So question 4, 3x plus 2y equals minus 8, and 3y minus 2x equals 14. So I'm going to call these equations 1 and 2. I'm actually even color code them just so we know exactly what we're doing. You can probably see it better on the screen. So let's call that equation 1, that equation 2. And we are going to rearrange one of them to substitute into the other. We've got coefficients on all of the x and y's, so I don't think any of them will be particularly easy than the other. I'm going to rearrange equation 2 just because it's already on the bottom and I can start working downwards. If I did equation 1, I want to write it out again. So equation 2, and I'm going to rearrange it for someone say x or y. X, cool. We'll rearrange for x then. Really doesn't matter. So I'll rearrange for x. So I've got a negative x, I want to make it positive first. So I subtract x from 2x from both sides, sorry. Gives me add 2x, 14 plus 2x. Then subtract 14 from both sides. 3y minus 14 equals 2x. Divide everything by 2. It's going to give me 3y minus 14 all over 2 equals x. We could simplify this to 3/2 y minus 7. I'm just going to leave it like this for now. It should. I won't. No, it'll be fine. So what we're now going to do is we are going to substitute this new equation, let's call it 3, into equation 1, because 3 is the rearranged form of 2. So x equals this. So let's take our equation. 3x is now 3y minus 14 over 2 plus 2y equals minus 8. So I've taken my new value for x from 3 and substitute that into this x on equation 1, and then I'm going to solve this. See, this is the reason I produce elimination here, because this is actually a bit of a not the nice thing I've ever seen. So we want to do this. So we're going to multiply the top line of our equation, our numerator, by 3 to make this 3 times bigger. So we get 9y minus 14 times 3, which is 42 over 2, plus 2y equals minus 8. Yeah, I think definitely the other method's better. It's quite unpleasant. So I'm going to come up here, keep manipulating it until we get a value for y. So we've got rid of our x now, I've only got y's left. So 9y divided by 2, I'm going to rewrite that as 9 over 2y, minus 42 over 2, which is 21, plus 2y equals minus 8. And I think I may have shown this before, and if not, remind me at some point, because it's a really useful thing to do. When you're adding and subtracting terms with fractional coefficients, 9 over 2y, a fractional coefficient, make every coefficient of that unknown, so y, make it a fraction 2 over 2. Make it a fraction over 2, because it makes it easier to add. So I'm going to change 2y into 4 over 2y. 4 over 2 is 2, so I've just exchanged 2 with 4 halves. It means exactly the same thing, so it's okay to do, but adding 9 halves plus 4 halves is much easier than 9 halves plus 2 wholes. So 9 halves plus 4 halves is 13 halves, so 13 over 2 y. Minus 21 equals minus 8. I'm going to add 21 to both sides. 13 over 2y. Add 21 to that makes 0. Minus 8 plus 21 is 13. And then I'm going to multiply everything by 2 to make everything a whole number. So multiply this side by 2. 13 over 2y is 13y. 13 times 2 is 26. Divide everything by 13. Gives me y is equal to 2. So, a seemingly simple solution for such a convoluted bit of work. So next I'm going to find our x value. So I'm going to take my x value and I'm going to substitute this y value into any of the equations, but I've got to remember which one I substitute into, so I want to test the answers then with the different one. So I'll substitute this value into equation 1. So equation 1. And I'm going to take my y as 2, so 3x plus 2y, 2 times 2, equals minus 8. 3x plus 4 equals minus 8. Subtract 4 from both sides. 3x equals minus 12. Divide both sides by 3. X is equal to negative 4. So those are my two solutions that I think are correct. Y equals 2. And x equals negative 4. But once again, we're going to test it by substituting both these values into another equation, either 2 or 3. They are the same equation, but a rearranged form. I'm going to go for 2, because 3 actually might be wrong. I might have rearranged it wrong in the first place. So let's check 2. So we'll do our check using equation 2, which is 3y, so 3 times 2, minus, minus 2 times minus 4 equals 14. So I've got 3 times 2 is 6, minus 2 times minus 4 is positive 8 equals 14. 6 plus 8 does equal 14. 14 equals 14. I'm happy. It seems to work, so let's stick with that. We'll go with those answers. They really do seem to work. So there was the method that they sort of wanted in the hint, use the same method of rearrangement substitution. However, I think it would have been easier to do it by the method that we're sort of maybe more comfortable with of elimination. So I will go ahead and do that just to show you how it's done. So I'll leave that there. That's it. I'm going to rub it off now. So I'm going to leave my two equations because they are the same. So y is minus 2, y is 2 and x is minus 4. Hopefully we get the same answers. So our elimination method is where we want to make one of the coefficients of x or y the same. It doesn't matter about the positives or negatives, as long as the actual number is the same. Obviously, we know minus 3 and positive 3 aren't the same number, but the number part is the same. So I'm going to, first of all, look at these here. So I've got a 3x here and a minus 2x, 3 and 2. It's going to be the same either way. So what I'm going to do is I'm going to go for x's again, because we did the first time. Why not? I'm going to make my x coefficients the same. So I'm going to multiply this whole equation by 2, because that'll give me that'll give me 6x. Multiply this whole equation by 3, because that'll give me a 6x. It's going to give me a minus 6x, but we still have the 6's in there. So my new equations are going to be 3x times 2 is 6x. 2y times 2 is 4y. And minus 8 times 2 is minus 16. Next, I have 3y times 3, which is 9y. Minus 2x times 3, which is minus 6x. And 14 times 3, which is 42. I'll go back to black, hopefully that's better to look at. And then we can see what we're going to do with these now. So now we have a 6x and a minus 6x. We think if we were to subtract one from the other, we're going to get 6x minus minus 6x, which is 12x, and 4y minus 9y, which is minus 5y. We haven't eliminated anything. So we're going to add them together. 6x plus minus 6x is 0, and that's what we're doing this for. So let's add our equations together. So 6x plus minus 6x is 0. Our x's are eliminated. And 4y plus 9y is 13y. Minus 16 plus 42 is 26. Yep. And therefore divide both sides by 13 gives me y is equal to 2. So straight away, we've got this same answer without that whole rearrangement and substitution part. So as I thought, this is probably the smarter way of doing this one. I think with question 1 and 2, the substitution method was the better method, but this was a bit convoluted when you did that. So once again, to find x, I'm going to substitute y equals 2 into one of my equations. Let's go for equation 1. Of course, you can do 2. You can even do these ones if you want. We'll go for equation 1. So substituting y into equation 1 is going to give me 3x plus 2 times 2 equals minus 8. 3x equals 2 times 2 is 4 equals minus 8. Minus 8 from both sides. 3x is minus 12, and x is equal to minus 4. These are the same solutions we got for the first method, so we know they're right. However, I'm still going to do the check to show what I would do if I were doing this whole question from scratch using the method we're using now. So I'm now going to substitute x is minus 4 and y equals 2 into equation 2. So 3y is 3 times 2 minus 2 times minus 4. X equals 14, and we know it's right, we've done it already. 6 minus 8, 6 plus 8 is 14, and it is indeed 14 equals 14. So in comparison to the last board of working, this is so much less, isn't it? We had 3 whole columns full of working last time, and now I've done it in 2 half columns. So I'm going to suggest that, yeah, that was the better method. So the crux of it is x is minus 4, y is 2 is the correct answer. Please tick if you have got that. If not, please make those corrections from this video as appropriate. Do remember to check your answers. You know, you will always get some form of simultaneous equation question in your GCSE paper. And we know we don't aim for tests, but we are here to pass tests as well. So please do make sure you do that check. And then if it is wrong, start again. Right, next question. This is going to overrun more than half an hour, but I've only planned for 3 half-hour slots this week, and we should have 4. So if we run over, it's not going to be too bad, hopefully. It should just fill in the 4th slot. Question number 5. So quadratic inequalities, actually, this is a grade 8, grade 9 question, quadratic inequality. So if you did do it, very, very well done. So here are 2 simultaneous equations, and I've got an x squared in it now, so it is a quadratic. And rearrange 5x plus y equals 4 to make y the subject. So they're giving us step by step. So 5a, let's go ahead and do that. 5x plus y equals 4. To make y the subject, we're going to subtract 5x from both sides. Y is equal to 4 minus 5x. B, substitute your answer into part A in place of y in the first equation. So we have x squared minus 2x equals 6 plus y. I I'll write out full plus y, which is x squared minus 2x equals 6 plus 4 minus 5x. Actually, sorry, gents, this wouldn't be a grade 8, grade 9 question. The grade 8, grade 9 question would be if you were to substitute in for x and then solve, expand the brackets and then solve the quadratic. But still, there's still a high grade 7 at least. So x squared minus 2x equals 6 plus 4 minus 5x. X squared minus 2x equals 6 plus 4 is 10 minus 5x. And then let's bring it all onto one side to give it equal to 0, and then we can solve it as a quadratic equation. So x squared minus 2x. Let's subtract 10 from both sides and add 5x to both sides, giving us 0. Actually, before I do that, is everyone okay with that step? Actually, tell me if you're not. If that step was a step too quick, let me know and I'll do it in 2 steps. I just taken 10 from both sides and added 5x to both sides, but I did it in 1 step. So x squared minus 2x plus 5x is 3x minus 10 equals 0. And now we have hopefully a nice solvable quadratic equation. So we look for numbers that multiply to make 10 and add to make 3. So 10 and 1 doesn't work. 5 and 2 could work. And obviously, one of them needs to be a negative because our constant here is negative. So one negative and one positive multiplied together make a negative. So we know it's going to be x and 5, x and 2. And then we're just going to think about how we could put in negatives and positives to make it work. So I need one of these to be negative. So minus 5 plus 2 would be minus 3. Doesn't work. Positive 5 minus 2 does make 3. Positive 5 times minus 2 is minus 7. So those are our 2 solutions. Oh, sorry, that's our factorized form, sorry. Then we can solve. So when 5x, I'm going to go to something. When 5x, I say 5x, x plus 5, sorry. If x plus 5 were equal to 0, so that were equal to 0, gives me x equals minus 5, because I subtract 5 on both sides. And when x minus 2 equals 0, x is equal to positive 2. So we add 2 to both sides. So now I've got 2 solutions for x, and therefore I will get 2 solutions for y. So there's my first solution for x. Let's find out what my solution for y could be. So I'm going to substitute that x into my equation here. Y equals 4 minus 5x. So y equals 4 minus 5 times x, which is minus 5, which is 4 plus 25. Minus 5 times minus 5 is positive 25, equals 29. And my other solution for x, y equals 4 minus 5 times positive 2 is 4 minus 10, which equals minus 6. Yes. And this part down here? Yes, sorry. So when x plus 5 is 0. Yeah, so sorry. So when x plus 5 is 0, makes x plus 5 equal to 0, which makes x equal minus 5. I think, did I say when that's 0, that equals 0? Did I say something wrong? Yeah. No, when x equals, when this equals 0. Oh yeah, I suppose so, yeah. No, because when this equals 0, that doesn't necessarily equal 0. They could both equal 0, But when that's 0, that's something else. That could be 1,000,000, that could be 5,000,000. When you times it becomes 0. Okay. So those are my solutions. X is -5 and y equals 29. X equals 2, y equals -6. Bit of a long one now, but we're going to check them both to make sure they work. And if they do, both solutions are valid. The question doesn't specify it to be positive end, does it? No. So there we go. We solve the quadratic equation as part D. And then E, substitute for X to find Y. Done. No, it doesn't actually ask us to do the check. So what I'm going to do is that's lazy of me. We'll do the check. We have to do the check. So let's go ahead and do it. So we'll take one of the unfortunately harder equations because we've used that one. We're going to use the other one now and substitute X and Y's in, see what happens. So I'll call this set of solutions A and this set of solutions B, and we'll try them both out. So my set of solutions A into our quadratic part here. So x squared minus 2x equals 6 plus y. So we'll do it A and B. So if for solution part A, x was -5, so -5 all squared minus 2 times x, which is 2 times -5, equals 6 plus y, which was 29. So we have -5 squared is positive 25. Minus 2 times -5 is positive 10. And 6 plus 29 is 35. 25 plus 10 is 35. 35 does indeed equal 35. So solution set A works. Let's now see if solution set B works. So for set B, is x is 2. So we have 2 squared minus 2 times 2 equals 6 plus -6. So on the left-hand side, we have 2 squared is 4 minus 2 times 2, which is 4, equals 6 plus -6, which is, 6 minus 6. We can see that already. 4 minus 4 is 0. 6 minus 6 is 0. Both solution sets do work. So if all the questions up until now were pretty easy and this one was causing a bit of trouble, again, please don't feel too bad because this is the beginnings of grade 8, grade 9 work. This is quadratic simultaneous equations. So we'll do a similar question from the very beginning, in question 6, and then I'm going to keep working through because I think the inequality questions were a bit shorter. So that's that for now. Pause it, print screen it, whatever. Not now, obviously. I will upload this to YouTube later for everyone who couldn't make it. Colin, if you need to go. I'm going to upload this whole thing to YouTube. So if you've got something, if you have to go, feel free to do so. But otherwise, I want to think about 5 more minutes on the next equation, and then questions 4, 5, and 6. Maybe another 10. We should be done by quarter past, 20 past. So question 6, solve the simultaneous equation. X squared plus 4x equals 4 plus y, and y plus x equals 2. So before I start, just think for a second, don't say out loud, just think for a second what you think a good first step would be. So this is one of those ones where it's going to be a substitution is the good first step, I think. Rearranging it for x or y. I'm going to go ahead and rearrange it for y, I think, because I think substituting in that y is going to be easier than substituting in something I have to square, something I have to times by 4. I think that's going to be more work there. I mean, we'll do the more work later, but I think it's a bit neater, I reckon. So I'm going to rearrange this for y. So I'm going to subtract x from both sides of that. So y is equal to 2 minus x. And now I'm going to take my equation here and substitute it into that one there. So that becomes x squared plus 4x equals 4 plus our y, which is 2 minus x. So I'll go back to black. Simplifying, x squared plus 4x equals 4 plus 2 minus x. is x squared plus 4x equals 6 minus x. 4 plus 2 is 6, obviously. And then bring it all onto one side, so it equals 0, and we can solve as a quadratic. So x squared plus 4x, I'm going to take 6 on both sides, add x to both sides, and that gives us 0. And we get x squared plus 5, x squared plus 5x, 4x plus x, plus 5x minus 6 is equal to 0. So this is a kind of, this equation jumps out at me straight away, and it's one of the ones that really annoys me, with a 5 as your coefficient, as your b coefficient in your quadratic, and 6 or any sort of 6 as your constant, because it can be 6 times 1 is 6, and 6 minus 1 is 5, and 3 times 2 is 6, and 3 plus 2 is 5. So we've got loads of solutions. It could be 6 and 1, it could be 3 and 2. Let's just work it and see which one works. So we know our bracket's going to look something like that. And then let's just see what works. So we'll try with, let's try first. Let's just try 3 and 2 first, why not? So we'll try 3 and 2 first. So it's a minus 6, so either 3 or 2 have to be negative. So let's try it with negative 3. So minus 3 plus 2 is minus 1. Doesn't work. Right, let's try it. Positive 3 and negative 2. 3 minus 2 is 1. It's not going to work, is it? So unfortunately, 3 and 2 aren't our ones this time. If that were positive, it could have been, but it isn't. So let's try 5 and 1. So 5 and 1. Let's try negative 5 and positive 1. Oh, sorry, I apologize, gents. 6 and 1. Sorry, 6 times 1 is 6, not 5 times 1 is 6. You thought I learned that by now. There we go. Minus 6 and positive 1. So minus 6 times positive 1 is minus 6. Minus 6 plus 1 is minus 5. It's always the last one, isn't it? No, it doesn't work. Positive 5 and minus 1, however. 6 times minus 1 is minus 6. 6 minus 1 is 5. It does work. So x plus 6 is 0. So x equals minus 6. And x minus 1 is 0. So x equals positive 1. So here are our two solutions for the quadratic. They feel right. Let's go ahead and keep doing the rest of the question, and we'll then find out. Right, so we'll substitute into our, let's go for this one here. So y equals 2 minus x. So y equals 2 minus x. So for our first solution, when x is minus 6, y is equal to 2 minus 6, which is 2 plus 6, which is 8. And when x is equal to 1, y equals 2 minus 1, which is 1. So our two sets of solutions are x equals minus 6, y equals 8. So there's one set of solutions. And the other set of solutions are x equals 1 and y equals 1. Circle. There we go. So let's do the check. So the check is now here. We can now do this. Let's chuck everything into this equation here. Actually, sorry, no, it's this equation here, isn't it? So we'll put everything in this and see if it works. So our equation is x squared plus 4x equals 4 plus y. And let's go for set A, let's call this. So x equal to minus 6. So we have minus 6 all squared plus 4 times minus 6 equals 4 plus y, which is 8. Minus 6 squared is positive 36. 4 times minus 6 is negative 24. 4 plus 8 is 12. 36 minus 24 is 12. 12 equals 12. We are happy that solution set A works. Let's now check the solution set B works too. So x is 1 and y is 1. So we have 1 squared plus 4 times 1 plus 4. No, sorry. Stop that line again. Should be an equals, not plus. 1 squared plus 4 times 1 equals 4 plus 1. X and y both 1. 1 squared is 1. 4 times 1 is 4. 4 plus 1 is 5. 1 plus 4 is 5. 5 equals 5. It does. Solution sets A and B both work. And thus, these are our solutions. There is no reason for us to disregard either sets of solutions. That is, this and this are both valid answers, so you've got to give all 4. On a GCSE question, they will ask you for both sets, and if you don't give both X and both Y's, you won't get the full marks.
How would the graph look with those with 4 different?
The graph would look like this if we were to draw these 2 graphs out, and then, if we draw the graphs out, and then where they connect, it would look something like this. You have a parabola and a straight line. So your 2 solutions would be, there's an X and a Y there that work, and an X and a Y there that work. So that's what the graphs would look like. So normally with simultaneous equation, we've seen where 2 lines cross, and they'll have this point of intersection. So if you have this graph and this graph, that point of intersection for X and Y are your solutions. When you have a quadratic and a linear, they would look like that. So you can solve the point of intersection of 2 quadratics, but not now, later, A-level. Right, so those are our solutions. I will quite quickly go through the inequalities and the inequality questions. You know, if you do have to go, please do dip out, but please do watch the end of the video in your own time. Let's quickly scrub this. I'm actually going to be quite quick, so I think if the video goes over 50 minutes, it becomes a big pain in the backside to upload to YouTube. So, relatively quickly, but hopefully still understandable, questions 4, 5, and 6. So question 4 was solving linear inequalities. There's no quadratic part. So question 4a was x minus 3 is greater than 5. Add 3 to both sides. X is greater than 8. Much like a linear equation, we're just solving an inequality rather than an equation. So there's an inequality symbol, not an equal sign. B. 7 minus x is less than 4. Let's subtract 7 from both sides, give me minus x is less than minus 3. And then we're going to multiply both sides by negative 1. Multiplying by a negative with inequalities. Never. Remember, we never multiply or divide by negatives. It doesn't work. X is less than 3 seems like the correct solution here, but it isn't. We always add and subtract when it comes to negatives. So what we're going to instead do is we're going to add 3x to both sides. Give me minus x plus 3 is less than 0. So I've added 3x to both sides. I then add x to both sides. Give me 3 is less than x, or x is greater than 3 if you prefer the x on the left, which is not the same as x is less than 3. Really, 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 really important with inequalities. Never multiply and divide by negatives. It flips the inequality sign, but we don't think about it like that. We keep it like here. So see, x is greater than 3, very different to x is less than 3. Yes,
but why couldn't you do it the same way you normally would and then just split that?
You can. So you could have done that and then just flip the inequality sign, but I guarantee you 99% of you will forget to do that in your final exam, so don't. It's one of those things that, you know, we don't like just remember to do it. We don't like that. We like to see why. Right, so 4C is minus 2 is less than x plus 1, which is less than 5. We're going to get the x by itself, so we're going to subtract 1 from all 3 parts. Minus 2 minus 1 is minus 3. X plus 1 minus 1 is x. 5 minus 1 is 4. So x is greater than minus 3 but less than 4. And D, 0 is less than or equal to x minus 4, which is less than or equal to 8. Adding 4 to every part of the inequality, so 0 plus 4 is 4, is less than or equal to x minus 4 plus 4 is x, and 8 plus 4 is 12. So x is greater than or equal to 4, but less than or equal to 12. Really important to keep those or equal to signs in there, because it does change the values that things could be. For example, this one here, x is greater than -3. So if x were an integer, it could be -2, -1, 0, 1, 2, or 3. It can't be 4 because it has to be less than 4. However, when it's or equal to, it can be a solution. So x is greater than or equal to 4. So an integer solution could be 4 or 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12, because it can be equal to 12. Right here, it was less than 4. Here it's less than or equal to 12. So 12 is a solution. Right. Nice and quickly, gentlemen. We are very, very nearly done. Thank you for bearing with me if you have. Question 5A, B, C, and question 6 shouldn't take a minute. So, quickly rub these off. (5A), we are solving 2 is less than 3x minus, that's not, what have I done there? 3x minus 1. So again, we're going to solve it as you would an equation. Add 1 to both sides, gives me 3 is less than 3x. Divide both sides by 3, 1 is less than x. This is a perfectly fine solution. However, I always like having my subject on the left. So I'm going to make that x is greater than 1. So these two things are identical. They mean the same thing. I just like having my x on the left. So it makes more sense to me that x is greater than 1 rather than 1 is less than x. Your choice. Right, 5B. (3x minus 1 is less than 11). So 3x minus 1 is less than 11. So we're going to add 1 to both sides. 3x is less than 12. Divide both sides by 3. X is less than 4. And then it says, find the possible integer values for 2 is less than 3x minus 1 is less than 11. So what we could do is write out that whole inequality and then solve it. Or we can be smart and think about what we know already. We've already solved both parts of that inequality. And so x is greater than 1. Also, it's less than 4. So it can only be 2 or 3. The only integers, whole numbers, that fulfill x is less than 4 but greater than 1 are 2 and 3. So you could have solved the whole thing by writing it out and then solving both sides, by adding 1 to both sides and then dividing both sides by 3, but you've already done it. And then the question 6 is one of those two-sided inequalities that we're solving. So we'll go do that, and that will be the same as what you could have done for 5C. So question 6, to finish the lesson, is 4 is less than 2x plus 5, which is less than or equal to 9. So we're going to find, does it say integer specifically? It does, the integer solutions. So we're going to subtract 5 from everything. Always do it in terms of the x, the part with the x. So subtract 5 from everything. 4 minus 5 is minus 1, is greater than 2x, which is less than or equal to 9 minus 5 is 4. Divide everything by 2 to get x by itself. Minus a half is greater than 2. No, we just divided by 2, apologies. 2x divided by 2 is x, is less than or equal to 4 divided by 2, which is 2. And then to finish the question, find all the integer values which solve this, which fulfill this rather. So x is potentially equal to, right, the next integer above minus a half is 0. The next integer is 1. Yeah, 1 fulfills that. And then, does 2 work? It does indeed, because it is less than or equal to. If this symbol, less than 2, 0 and 1 are our only solutions. However, it isn't, it is or equal to, and so being equal to 2 is a solution. X could be 0, 1, or 2. Right, gents, I hope that was enlightening. Any questions before I go and have a lie down, because I'm exhausted? No questions, no questions, no questions. See Alex. Right, gents. In that case, I am going to go. Thank you so much for being here for me. Those who can make it. I want to take the list of the 10 people who are here, plus Alex just went, and Jackson I think's gone already. I'll make sure everyone gets noted for being here. So thank you very much for being here. I hope it was enlightening. I will try and do more of these because I'll be coming into school more often. In fact, you guys are in school next week as well. Right. Yeah. Stay safe.